We use use cases to understand the boundaries of our design, the boundaries of our problem. In this example, I want to show you how to revise a use case if it looks like your design is going to be extremely complicated. So this will help you make your design more straightforward, especially if you have a lot of exceptions in the use case that you're describing. So I want to begin with one of my favorite use cases. A user makes an espresso. This is with a super automatic espresso machine. We only have one actor, who is the user, and we have one precondition, which is that the boiler is at the correct temperature. So if the boiler is at the correct temperature here, we think we're ready to make an espresso. So here's our description. In this case, the user only has to do one thing. It presses a button called coffee, and then the machine grinds the beans, which are available in the bean hopper, and then it dispenses coffee once it's done grinding. So it's a pretty easy description. If you've ever used a super automatic espresso machine, you may recognize this as the way that it works. So we need a few more things to talk about the use case in its full extent. So there are a few things that could go wrong. The machine can run out of beans. This is not good. Then our coffee won't taste very good. Another thing the machine could run out of is water. If the machine runs out of water and tries to pump air through the boiler, then bad things could happen. Also, the user can change their mind partway through. So they can change their mind on the amount of coffee that they want during operation. And the user can also change their mind about the amount of coffee that they want to grind. So the first of these, the amount of coffee, is the amount of liquid they expect. That's exception number 3. Exception number 4 says that they want to change how much grind they want. That is, they decide after they start making the coffee that they want to grind more beans to be part of their espresso. We only have one post condition here, which is that the machine will indicate the current state at the end. So there are lots of states the machine could have. It could still be needing to warm up. It could be it needs to be cleaned, etc. So we're just going to leave it as a post condition that the machine will indicate its state. So these two exceptions make for a really complex state of the system. So we have to constantly be monitoring how much beans we have while we're grinding the beans. And then what happens if we run out of beans while we're grinding? So this means that we're going to need to have a lot of exceptions that are part of the design of the operation of the machine. We can also think here, with the machine runs out of water, that we might need to immediately stop what's going on. So this also makes our design a little bit more complicated. So here's the idea. I'd like to be able to get rid of these exceptions by revising our use case to assume in our preconditions that we have plenty of beans and we have plenty of water. So this will allow us to mitigate our design complexity by making sure that we'll never encounter these exceptions while the machine's in operation. So here's our original use case. The user makes an espresso. The actor is a user, and our precondition is that the boiler is at the right temperature. And then our description says exactly what will happen. The user presses the coffee button, the machine grinds the beans, and dispenses the coffee. So now I'm going to add 2 more preconditions, and you can probably already guess what they are. My first precondition is that I have sufficient water and that I have sufficient beans. So these remove the possibility that we'll run out of water or run out of bean as an exception. So our revised exceptions are the following. Now that we have new preconditions, I can get rid of these 2 exceptions, which is going to give me an updated list of exceptions, like so. So now the only 2 exceptions we can have are that the user changes the amount of coffee during operation, and the user changes the amount of grind during the operation. The post conditions are the same, the preconditions are all that's changed. And suddenly we now have a much easier design. So if you want to think about the preconditions, for example here, basically we will now start to ignore when the user presses the coffee button if any of our preconditions are not met. So our preconditions are guard conditions on going into the initial state of the dispensing the espresso for this particular operation. So we're using to our advantage the knowledge that things could go wrong, and if the things have even a remote possibility of going wrong, we're going to prevent the user from taking that incorrect action. So just a reminder here, our use cases permit us to define the boundary conditions of our project. The first is that we'd like to decompose our scenarios. The second is that we want to decompose the effort of those scenarios in order to allow us to do concurrent design and implementation. So the more use cases you have, the easier it is to do things in parallel or concurrently. So we're reducing our exceptions at the cost of more use cases to reduce the complexity of our design. So this means that fewer people need to be involved for each particular use case's implementation. Even though we'll have more use cases, we can carry out the design and implementation of those use cases concurrently, which prevents us from having large designs that only one person may understand.